Hello, this is Jyotika. Welcome to Excelling Psychology. In today's class, I will be solving Spearman's row correlation sums, which will be useful to you for your Edexcel, GCSE and IAL A-levels courses. In the syllabus specification, if we see, they have mentioned that you have to know how to solve all the steps of Spearman's row sums, though you need not know the formula. On the screen right now I have from one past paper how the formulas are given in the question paper. So this is what you're seeing on the screen is a sample of a question paper in which they have given the formula for Spearman's rank order coefficient. As mentioned in the specification, you need not memorize it because it is there in the paper. Definitely the critical values are also given in the paper, but the steps are what you have to know by yourself. I know if we look at the past papers, mainly Spearman's row questions have come in the form that they have completed nearly all the steps in the paper. Only the last two columns, difference and difference squared, are left to the student. Sometimes one of those columns, sometimes the last column, and the final answer to be calculated up to 2 or 3 decimals, that is left to the student. This does not mean that in future they cannot ask for any of the other columns to be filled or for more steps to be performed. Just because something has not come as of now in the past papers does not mean it will not come in the upcoming papers. Keeping that in mind, I am going to solve the full sum and demonstrate to you, and it is my very strong opinion that you should be knowing every step as well, because that is what the specification says. Okay, so today let us learn how to solve one complete Spearman's row sum. In this solution, I will be showing you right from step 1, from proposing the hypothesis till the very last step of looking at the critical value and taking a judgment on whether the correlation coefficient is significant or not. The entire process I will be explaining to you. It is going to be a lengthy video, but it is worth doing this lesson at least once in your syllabus, though I would recommend that you solve many Spearman sums, as many as possible. Here we have a question. The question wording is not very important, but just so that you understand what the sum is about, I am reading it out. Following are the scores of students on the psychology and sociology test respectively. Calculate Spearman's row correlation to investigate whether students who obtain high scores on psychology also obtain high scores on sociology. We should just take a look at the wording of the question. Those who get high scores on psychology should also get high scores on sociology. It's not like they're expecting that on one subject, if they're getting high scores, they should get low on the other. In that case, it would be negative correlation. But here, they are implying a positive correlation. This is important for framing the hypothesis. That's why we are taking note of this. Otherwise, like I said, the question is not very important. Instead of psychology and sociology scores, if it was some other scores that were given, doesn't matter, the steps and the technique is always going to be the same. So here we have the raw psychology score and the raw sociology scores. Let's begin with calculation of Spearman's row. I have deliberately not printed out the answers already because I want you to solve this sum with me step by step. So keep your notebook ready and start solving with me so that you understand how to carry out all the steps. For statistics, it's a very poor strategy to just read a sum in the textbook or to just sit and watch someone else solving the sum as if some TV show is going on. That does not help you to solve sums in the paper. That's not a good strategy for theory either, but especially for statistics, just watching someone solve something is not going to help you. Be proactive. Start solving the sum along with me. keep on pausing the video, keep on doing the steps first by yourself and then cross-checking whether you're getting the same answer with me or no. The more you'll practice, the better you'll get at it. Step 1 in the solution of Spearman's row sum is to propose the hypothesis. In the Edexcel paper, you will not have to do this step-by-step solution. Definitely there will be some steps which are missing and you'll have to solve. Still practice it in the way that I'm practicing for full clarity of the process. I'm going to propose what is called a one-tailed or a directional hypothesis, because like I showed in the question, there is an implication of a positive relationship. So the hypothesis I am proposing is, there is a significant positive correlation between scores on sociology, psychology test and sociology test. I'm just going by the order given in the question. I'll also specify that this is a directional one-tailed hypothesis. Next step is always to start doing the steps for Spearman's row, which just means preparing the table for the sum. So step 2, we can call it anything, we can call it Spearman's row table, because anyways, like I said, we are writing these steps just for our knowledge. This is not how we are going to be solving in the paper. So you can give any name to the step which will help you remember later on what exactly is to be done on that step. A Spearman's row table will always have 6 to 7 columns. Why I'm saying 6 to 7? Because most of us prefer having one column with serial number. So if I take that will make for one extra column. It means totally there will be 7 columns. But if I don't make that, then in that case there will be 6 columns. So 6 columns at a minimum. And the number of rows that we have to take on the table depends on the number of scores which are there. So I can just count mentally. In the paper, don't make any marks on the question paper here, because I'm demonstrating, I'm just showing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 rows that are required to fill in the data. Besides that, I will need 1 row for headings and 1 row I will need for the totals that I need to calculate below the table. So in total, I will take 12 rows. Columns, like I said, I will take 7 columns for my Spearman's table. Okay, so first we should make a neat framework for the table. In the paper, the table will be drawn out, but when you practice, make sure to make a neat table. Don't do things haphazardly. Later when you refer to your notes for revision or practice, it becomes difficult for you only to follow what you have done. Okay, so I will take 7 columns side by side. Now I will give the column headings. The first column I will label as number, because that's just participant or serial number. The second column I'll label as X. X simply means scores on the first variable. In this case, it is scores on psychology test. Next is Y, which is scores on the second variable. In this case, it is scores on sociology test. Next will be ranks. I'm denoting it as R. We will see how to award the ranks. This is going to be ranks for the variable X, so I'll call it Rx. Then next will be ranks for the variable Y. Then there is difference. We can write capital or small d. Generally they use small d, so I'm using the small one. And then there is difference squared. Now I will first fill the first column, just giving the numbers in serial order. Okay, why I have written 10 numbers? Because there were 10 participants whose scores are given as we had marked on the question paper. Under the X column, I just have to copy from the question paper which numbers are given. So all the numbers given under psychology scores, I will be writing under X. So quickly I'll just fill that up. Okay, so I've just copied out all the numbers from the question paper. So till here we haven't done any calculations. Now we will start doing the actual steps which are required. Under ranks X, what we have to do is we have to give ranks in ascending order to the values which are under column X. So what we have to do is we have to take the lowest number in the X column and we have to reward it with a rank of 1. You have to just find the smallest number in the X column. So the number which is the smallest or the least value we can see is 21. We will assign it a rank of 1. Simply we will write number 1 in the rank column where we can see 21. On that row we will write 1. Now we have to keep on progressing in this order, in ascending order. Once we are done with the number of the least value, we'll find the number which is the next least value or which is just higher than 21, because we want to assign the next rank to that number. We want to assign the rank of 2. So the number which is greater than 21 we can see is 23. There are 2 occurrences of 23. Now this can be confusing. Which of these 23 should get rank 2? I want to give rank 2, but there are 2 numbers. So which one should get rank 2? It's as if in your class there are 2 students who have got equal marks. Now who should get the second rank? What we do is, to be fair, we give the average rank to both the occurrences. What do I mean by the average rank? I'm showing below the table just as rough work. When you're solving, you don't need to show these steps. It's just for your understanding. Rank 1 has already been assigned. The next rank is 2, which I want to give to 23, but there are 2 occurrences. Because there are 2 occurrences, I will have to consider the next 2 ranks which could be awarded. So one is 2 and the other is 3. Now I have to take the average of these 2 ranks and assign that average to each of the occurrences. So first let us calculate the average of 2 and 3. The average of 2 and 3 is, as we would expect, 2 plus 3 upon 2, which is 2.5. That means wherever now I see 23, in those rows under rank X, I am going to write 2.5. Now, once I have assigned rank 2.5, in the process I had considered 2 and 3. That means in my mind I have to keep that ranking 2 and 3 is complete. Now I cannot give any score the rank of 3. I want to emphasize on this. This is where students make mistake. After they've given a rank like 2.5, they will try to give rank 3 to the next score. You can't give the rank of 3. 3 is already completed when you were calculating the average. Now the next score you will have to give rank 4. We have to progress in the same way like we saw. Now we have to see which score is higher than 23, which is the next least score which is there on the table. So that is 25. Again, there are 2 occurrences of 25. I wanted to give rank 4, but there are 2 occurrences. So what I will do, I will consider the next 2 ranks, 4 and 5, and I'll take the average of these ranks. So same process which we did earlier. So 4 plus 5 upon 2 will be the average, 4.5. Now both occurrences of 25 will get rank 4.5. What I have to be very careful about is, because I have considered rank 4 and 5 in the process of assigning the ranks, up to rank 5 is completed. Now the next least score, which is there, I will not give the rank 5, I will give the rank 6. Means in my mind I have to keep the rank 6 now. I should not keep rank 5 in my mind. Let's see which is the next least score or score higher than 25. It is 32 and it has only one occurrence. So we can give directly rank 6, which we want to give. We don't need to distribute it. After 32, the next least number or higher than 32 is 33 and there is a single occurrence. So we can just directly give the next rank 7. After 33, the next least number is 45. We can give it the rank 8. So you can see numbers I am considering in ascending order and ranks I am giving in again ascending order, lowest to highest. Next least number is 64, which can be given rank 9. And next least number is 65, which is actually the highest number. It can get rank 10. So this is how we assign the ranks for any variable. Now, if there are no tied ranks in the last position, like we just saw 65 had only one occurrence. In that case, this number which is there, the last rank which we give, should be equal to the total number of scores or the total number of participants. That's just a cross check we can see to keep in mind that we are doing it correctly. So we can just check the last rank we are giving should be equal to total number of participants unless there's a tied rank. The same way we have to rank the variable y. So this is good, it will give us practice. Doing this column will give us further practice into assigning ranks. So now, keeping the y column in mind, looking only at the y column, we will give ranks for y. Okay, in the y column we can see the least number is 20. So we will assign rank of 1 to 20, means again we will go in ascending order. The next least number is 21. This we will assign rank 2. The next least number is 25. This will be assigned rank 3. Next least number is 29. It will be assigned rank 4. Next least number is 31. It will be assigned rank 5. Next least number is 33. It will be assigned rank 6. Next least number is 40. It will be assigned rank 7. Next least number is 60, but it has 3 occurrences. 3 occurrences and I wanted to assign rank 8. So now I'll just show below. I wanted to assign rank 8, but there are 3 occurrences. So I will consider the next 3 ranks, 8, 9 and 10. So I will have to take the average of these to assign the rank to the score 60. Average of 8, 9 and 10 is going to be 8 plus 9 plus 10 divided by 3, which comes to 9. You can literally do the calculation. If it's not easy for you, you can do it on the calculator or manually. If you do 10 plus 9, you get 19. 19 plus 8, 27. There is no shame in doing calculations if you're not able to get it immediately. Make sure to do as much calculation as required by you and then only write the answers. Be sure to be correct. Don't think about you should be doing it or not. 27 divided by 3 is 9. So you can get it this way also. And if you find it still difficult, you could do it in the calculator. 10 plus 9 plus 8, press the equal to sign and divide it by 3. You get 9. So 9 is the rank which you have to assign. So now for all occurrences of 60, I will give the rank 9. In this case, the last rank which is there is not the same as total number of participants, because like I had mentioned earlier, if there is a tied rank, in that case you will not get the same number, but still you will get a high enough number. So just roughly you can check that it is close to the total number of participants. Okay, so that is how we do ranking. Now coming to the difference column or D. Before I come to difference, just 1 or 2 minor things that I want to discuss. One is for your practice, though you won't have to do it in the paper. It can be good to just list out what the headings of the columns mean, just for your knowledge. And in senior years, if you take psychology, ahead in your degree college, there it can be useful for you to do these type of practices. In statistics, whenever we use some short forms or abbreviations to denote anything, it is good to just point out what symbols, what notations we have used. So X is scores on psychology test, Y is scores on sociology test, RY is ranks of Y, RX is ranks of X, D is difference in ranks, and D square is square of difference. Okay, so as of now it's a key for your knowledge. In future studies, if you pursue psychology, there it can be useful for you to be mindful of writing the use notations in this way. Okay, now what we have to do for the difference column, what we have to do for difference is simply use a formula which is called Rx minus Ry. Whichever rank is in the X column, from that you have to subtract whichever rank is on the Y column. Means here in the first, whatever I'm writing in red, you don't need to show in the paper, it's for your knowledge, but what you're doing mentally is what I'm pointing out in red. 8 minus 7, which is plus 1. So in the paper, if the D column is blank, you just have to write plus 1, or you can even just write 1. But mentally you have to think of it as 8 minus 7. In the next row, you can see under Rx we have 2.5 and under Ry we have 6. So what we have to do mentally, 2.5 minus 6. And that is what we need to write here, the final answer, which will come to minus 3.5. For a negative number, it is important to show the sign. I feel it's desirable to show for positive numbers as well. But many students don't like to put a plus sign in front of a positive number. In that case, you can make sure at least for the negative numbers you're putting the sign. Again, it's not a matter of shame. If you find the calculation difficult, open your calculator, do the calculation in that and write the answer in the column. You are allowed to carry a simple calculator in the exam hall, as you know. Make use of it. Be accurate, that is more important. Okay, now this way you have to progress through the entire column. So next you can see on rank X there's 2.5 and on rank Y there is 3. So minus 0.5. Okay, now I will not keep writing in red for each. I hope you have seen the pattern of how we are calculating. So now you just have to keep on continuing in that way. So for the next one we'll have to do 9 minus 2, which is plus 7. Next we'll have to do 10 minus 9, which is plus 1. Next is 7 minus 9, which is minus 2. Next is 4.5 minus 5, which is minus 0.5. Next is 4.5 minus 9, which is minus 4.5. Next is 6 minus 4, which is plus 2. And the last is 1 minus 1, which is 0. You do not have to total this column, but as a cross check, just to make sure you're on the right track, because many students become anxious about any math solutions. Just make sure you, on the calculator itself or mentally, you can just add up this whole column, the whole D column, and the answer should come to 0 if you have calculated correctly. So if you take all the positives on one side, you just add all the plus values, and then you just subtract all the negative values, the result should come to 0. So that will tell you have done it correctly. Okay, now let's do the D squared column. In the D squared column, what you have to do is, whichever value is on the previous column in D, you have to square it. Square means you multiply that number by itself and you write the final result. Here the value is plus 1. So what you have to do is plus 1 into plus 1. You multiply the number by itself. Again, what I've written in red, you don't need to show in the paper, but that's what you're doing. And then the final answer, which is 1, you just write that over here. Okay, the next value you can see is minus 3.5. So what you need to do mentally, minus 3.5 into minus 3.5. In many calculators you will have the squaring function. As long as it is not a scientific calculator, you're allowed to use that. But right now I'll assume that you do not have the exponent or the squaring function. In that case, I'll show you how to multiply the number by itself on the calculator. Do not consider any step trivial. There are many students who struggle with these steps, so I have to show them. Okay, so if you know the answer, well and good, write it directly, or if you know a better way of doing, do it. But why I'm showing all the steps very finely is because there are many students who need help with these steps. 3.5 you have to press on the calculator. Press the multiplication sign. Again press 3.5. Press the equal to sign. Whatever result is coming, just enter that in the cell. Now this you must have noticed it is minus 3.5, but I have entered only 3.5. When we multiply negative numbers by themselves, or when we square a negative number, the result is always positive. So while squaring, we can treat it as a positive number. Squares, you need not write signs ahead of them. In the difference column, why we have written signs ahead like positive and negative? Because those numbers carry signs. But squares are always positive, so we don't need to put plus and minus signs. So here we can straight off write 12.25. Okay, in the next row we can see the value minus 0.5. So on the calculator, once again I will show 0.5 into 0.5, 0.25. Alright, so this is how you have to keep on progressing through the column. Next value is 7, so 7 squared is 49. Next is plus 1 squared is 1. Next is minus 2 squared is 4. Next is minus 0.5. Just be mindful of values you have already calculated previously. The same value of course will come next to this one, so you don't need to calculate again. This can save you time. Next is minus 4.5. This I would like to do on the calculator. 4.5 into 4.5 gives me 20.25. Next is plus 2 squared is 4. Next is 0 squared is always 0. So this is how we complete all the columns, data columns, in the Spearman's row table. Now what we are left with is the column totals. For which columns we need to take the totals? For the first one, it's just a count actually, it's not the total, but it will help us see what is n. N is just total number of scores or total number of participants. We just have to count, keep it in mind, we don't have to sum the column. So how many scores are there on this column? 10. So n will be 10. Okay, and we need to sum or total the last column. In the Spearman's row sum, we need to sum d squared. This we denote as sum, the summation symbol d squared. Okay, let's just add up all the values. So 1 plus 12.25. You can see I'm just adding all the values like this vertically on the last column. Plus 0.25. Plus 49. Just be careful when you are entering to maintain the decimals as they are there. Plus 0.25 plus 20.25 plus 4. This gives 92. So sum of d squared is 92. So what does n stand for here? Total number of participants or scores. And sum is the summation symbol or sum of or total. Okay, so far which steps we have completed is proposing the hypothesis and preparing the table for Spearman's. Next is to use the formula and do the calculation of the final Spearman's row value. Now if you practice enough sums, you will know the formula by heart. It's very simple also, but you don't have to memorize for the paper. They'll always give it in the paper. Okay, so let's take step 3. calculate Spearman's row value. Now, first you should write the formula in the paper. Once I'll show in the paper also in some future video. There's a blank space on the left, steps for calculation. In my previous video also you can see that. There you should write the formula once, show the substitution in the formula, and then give the final answer in the blank space which is given for the final answer. So writing the formula, like, it helps you also to stay away from errors. That's why you should write it. So formula for Spearman's row is just 1 minus sum of d square divided by n into n square minus 1. I'm just highlighting the formula. This formula, like I said, you need not memorize as such. It is there at the beginning in your paper where I had pointed out here. You can see 1 minus 6 sum of d square upon n divided by n square minus 1. Now just one or two things before I do the calculation. One is small n should be used or capital N should be used. Ideally small n should be used because it is sample, it's not the population. Still you can see as I have written capital N, that is also fine. Why I have written that is because most students note this value on the tables. This is what we are taught in maths from the beginning. So just for ease sake I have written that way. Otherwise simply on the table where I have written capital N, you could write small n instead, and in the formula also you could use small n. Another is one of the most popular textbooks which is there on this subject, which most students use. There are, I think, around 3 very popular textbooks. Out of that, one of them which is there, excellent book. The same author who's written the GCSE textbook has written this textbook as well. In that you'll see the formula is slightly different. It is n cube minus n. I think it's something like this. What the author has done is simply expanded the formula which is in the denominator. So what they have done is instead of putting the bracket value, they have taken it this way. You can write the formula this way also, it's not wrong, it's just more elaborated, like it's more expanded. So nothing wrong with writing that. Even if this is the formula here, you can use this one, there's no issue. Right now I'm using this formula, either formula is correct for the paper. Okay, so let's come to solving the sum. Once we write the formula, we should just start substituting the values. It's very easy from this point onwards. So what we can write, therefore, we can make the symbol for row now. You know symbol for Spearman's row is this. So Spearman's row is equal to 1 minus, in the numerator 6 into sum of d squared. Just see your table, in the end there you will find you have calculated sum of d squared. That value only you are required to substitute on the numerator. So 1 minus 6 into 92 divided by, in the denominator we can see n. Again on the table we have noted n. N we have noted as 10. So we have to take 10 on the denominator. 10 into, again n is there, so 10 squared minus 1. Okay, so now we can keep on solving. From this point onwards we've completed the substitution. First for the numerator we just have to multiply 92 into 6, which comes to 552. In the denominator, first following the BODMAS rule, we should solve the exponent and what is in the bracket. So we'll keep 10 as it is outside. In the bracket we'll solve 100 minus 1. Again, I know students like to skip some steps and be fast and just do everything on the calculator and write the final answer. But I am showing it step by step so that you do not make errors. And especially for students who tend to, in overconfidence or in an unnecessary hurry, make a lot of mistakes, for them I strictly advocate doing each and every step systematically, because it's not worth losing your marks in a sum in which you can score full marks. Okay, so 1 minus 552 divided by, now we can open the brackets, in the sense we can do the multiplication. So first we just have to multiply 10 into 100, which comes to 1000. And then we have to subtract 10, because we are doing 10 into 1. So minus 10. Okay, now we solve it further. 1000 minus 10 becomes 990. Now we have to remember the 1 is outside. Many students prefer writing 1 over the lines like this, over the rule notebook. That reminds them that first they have to solve the fraction and then only they are to subtract the fraction solution from 1. So either write it this way to remember, or if you're just writing 1 on the numerator side, remember that first you must solve the numerator, the fraction, and then subtract from 1. Don't do 1 minus 552 and then divide by 990. That will be wrong. So what you have to do exactly is divide 552 by 990. Okay, and this value you will have to subtract from 1. In the final answer in the paper, mostly they mention take up to 3 decimals, 2 decimals. I'll come to that in the final answer. Right now, in the intermediary steps which are there to coming to the final answer, just keep on taking 3 decimals. So 0.558. Okay, now I'll do the subtraction to get the final row value. 1 minus 0.558, which comes to 0.442. Okay, I am retaining a 3 decimal value for the final answer. Also, it is very important at this point to show the sign. Correlation can be a positive or a negative value. In this case, we have obtained a positive value, so we should just put a plus sign ahead of the correlation coefficient. Okay, so this is how we have done step-by-step solution for Spearman's rule. Now the next step is, we had proposed a hypothesis in the beginning to check whether that hypothesis is supported or not. So checking for significance. In the theory, you must have learnt that just because we have got a sample value of, say, this plus 0.442 does not mean that it is necessarily true for the population. So we have to check for significance. Today I'm not getting in the theory behind statistics, but checking for significance is obviously very important. After all, it's an inferential test that we are doing right now. Okay, now the row value which we have got, one thing I just want to say, according to APA format, which is generally followed in psychology, we take up to 2 decimals, the correlation value, when we want to report it in results of a study. But in the paper, mostly I have seen in the Edexcel paper, they insist on taking 3 decimals. That is why here I have taken it up to 3 decimals. Okay, so now checking for significance, we need to know what is the critical value of rho. Means what is the value on the table or the tabled value. For that we have to take note of n again. So we can write since n is equal to 10. And we want to check at 5% significance, 0.05 significance. Why I am saying 0.05? Unless they have specified otherwise on the paper, the convention is to take 0.05 level. Okay, so significance level is 0.05. And the nature of the hypothesis, that's the last thing we need to consider. Is it one-tailed or two-tailed? There is one-tailed hypothesis, the directional hypothesis which we give. So accordingly we will check on the table and we'll write the critical value. I'm just making a space for the critical value right now, then we'll look at it on the table. Also, again, many students will just see the past papers very superficially and they will see that the sums have just ended with giving rows value. But if you look at the papers more closely, you'll realize there are other questions, not necessarily the sum question on row, in which they do ask about checking for significance. So this is not unnecessary. One, like I said, in the future they could ask you for any other steps, so checking for significance could be asked even if it has not been asked in the past papers, and independently in other questions besides the sums. If you see in past papers also, they have asked to check for critical values. Now the table is something you cannot memorize, you will have to look at it on the table, on the paper. How do you look at the table? Firstly, you locate and make sure you're looking at the table critical values for Spearman's rank. Because it's rank order correlation, they just call it rank instead of row. Now, why I'm saying this, because there's also chi-squared table. So as silly as it might sound, make sure you're looking at the Spearman's table only. Next is you look at your hypothesis, whether it's one-tailed or two-tailed. According to that, look at the significance level. Right now we are looking at one-tailed, so I am going to look under one-tailed for 0.05. right? I just need to ignore whatever is given. This is not relevant to me under two-tailed. So to avoid confusion, just don't look at those values. Okay, so just look under one-tailed. 0.05 is what you want. Now what is your n? 10. We had noted for this sum our n was 10. So taking 0.05, going down the 0.05 column and horizontally taking 10 and coming to where these two intersect. This is the value which is significant, 0.564. And this value on the table is always applicable to both a positive and a negative coefficient. It is not meant only for positive coefficients just because they have not put the negative sign. Okay, so what we need to do is, where we've written critical value of rho, we must just write 0.564. I've just copied it from the table. So what is essential is you should have the reading skill for the table. Now what is the calculated value? Just let's reiterate that. Calculated rho value is this one plus 0.442. Now what is it? Is the calculated value greater than the critical value or is it lesser? It is lesser. So we can just show that calculated rho is lesser than critical rho. Means we will have to accept the null hypothesis. The directional hypothesis which we have proposed is not supported. I won't say we'll have to support the null hypothesis because actually we have not proposed it. So simply we'll say that the hypothesis is not supported by the data. Supposing instead of this, if it was a negative value, in one of the past papers it was such that it was a negative value. I think it was something like, let's assume, I'll give you a hypothetical. If this is the critical value, the result which students calculated on that sum, it was a different sum, it came to minus something 0.772 or something. In this case also, you will have to say that your hypothesis is not supported. Not because this value is positive. Don't make that error. That is because you proposed a positive correlation. That's what your hypothesis is saying, but the value is coming to a negative correlation. Okay, so what your hypothesis says, exactly that expectation should be met for you to be able to say that the hypothesis is supported. In any way, if that prediction is not met, you will have to say that it is not supported. So coming back to our case, the calculated value is not showing significance because it is less than the critical value. So what we will have to say is, therefore, the hypothesis proposed is not supported. Okay, so for A levels or GCSE GCE, in fact, is simpler. They don't even ask this much of calculation, like 1 or 2 columns. They barely ask about Spearman's correlation if we see the papers so far. So considering that this is how much we need to practice and know about calculations of Spearman's rule. One more thing before I forget, I just forgot to mention that you don't even need to memorize for your A levels or GCSE whether the calculated value needs to be greater or lesser than the critical value, because there are some inferential statistics in which the way of checking is the opposite, in the sense the value has to be lesser than the table value for it to be significant. So they have mentioned below the table, so you need not worry about remembering the rule for checking the hypothesis. Here you can see calculated value must be equal to or exceed, means it must be more than the critical value for significance to be shown. So they always give the rule under the table itself. So don't worry about being confused how you need to support or see whether the hypothesis is not supported. It will be there on the question paper. I think that's it. I have covered all that I wanted to show about Spearman's row correlation. If you have any doubts about what I have shown on this video, you can comment in the comment box below. I will come up with another lesson soon. That's it for today's class. Thank you for watching.